Okay, in this section, we're talking about bond polarity. Bond polarity is mainly depend on the electronegativity. By looking at the electronegativity difference between two atoms involving in the bond, we can predict um, what type of bond is that. We have ionic bonding and covalent bonding. Depending on how these in covalent bonding, how these electrons share, electron pair sharing between these two atoms, we can further divide covalent bonding to nonpolar covalent and polar covalent bonding. So, if you what is this polar covalent and nonpolar covalent bond? Polar covalent is when uh, first let's look at nonpolar or pure covalent bond. If if the electron cloud between these two atoms, if you see here fluorine, equally sharing between these two atoms, we call that as pure covalent or nonpolar covalent. But if one atom involving in the bonding, in the situation hydrogen fluoride, what is co-electronegative? Fluorine. Fluorine electronegative because of that fluorine pulls electron cloud towards itself because fluorine is more electroaffinity. It has more electron affinity towards electrons, so it pulls electron cloud. So now electron cloud is not equally sharing between these two atoms. At that time, fluorine has higher electron density than hydrogen. So fluorine has little bit more negative charge. We call that as a temporary dipole, little bit polar. So it gives a little bit polarity to the molecule. Similarly with the lithium fluoride, fluorine pulls electron clouds harder and lithium doesn't have any electronegativity, very small electronegativity. This these bonds are we call polar covalent because electron cloud is not equally sharing. So covalent bond, if the covalent bond equally sharing these uh, elect electron pair between these two atoms, we call it is pure covalent or nonpolar covalent. But if one atom is more electronegative, pulls electron clouds towards itself, we call polar covalent. And then not sharing even this time, completely transfer electron from one atom to another, we call ionic bonding. Okay, so how this electronegativity come to the picture? If you think about any atom, any compound, let's take hydrogen HCl. Hydrogen electronegativity is 2.1, chlorine is 3, electronegativity difference is 3 minus 2.1, 0.9. Electronegativity difference comes here, bond is polar covalent. Let's take Cl2, chlorine. Chlorine, Cl, Cl, electronegativity difference is 0, electron shared equally, bond is pure covalent. Sodium chloride, sodium is 0.9, chlorine is 3, electronegativity difference is 2.1, bond is ionic. That's how you predict what type of bonding is that. So, and then you can, so now strontium fluoride, anything you can look at the electronegativity and then find electronegativity and then take the difference and then find which range is that and then you predict whether it's a covalent, polar covalent or ionic. And then I wanted to show you another thing, Lewis structures. Writing Lewis structures is very important. We use writing Lewis structures in the next chapter 2 in bonding. There's a way to draw Lewis structures, very easy. I'll explain you. Always when you draw Lewis structure, the center atom should have center atom and all the other atoms has 8 electrons. So this is example how to draw Lewis structure for what is this? Phosphorus trichloride. First step, identify the center atom. So what is a center atom? Center atom is what is the atom that all the atoms bonded to. So center atom is least electronegative element. But there's exception. If you have hydrogen, hydrogen can never be center atom. Hydrogen always goes to the terminals. Other than that, least electronegative atom comes to the center. In this case, phosphorus and chlorine. Least electronegative atom is phosphorus. It comes to the center. Once you identify center atom, next step. Calculate valence electrons. How do you calculate valence electrons? Phosphorus, 5. How do you know it's 5? You look at the periodic table, group 5. Chlorine, group 7, 7. So that's what I put. 5 is for phosphorus. Cl7 into 3, 26 valence electrons. Your next thing is, okay, you know phosphorus is center atom and then chlorine goes to the terminals and then distribute this. So now, okay, and then, okay, you each line represent two bonds, one, two electrons, 1, 2, 3, 4, 5, 6. 6 electrons gone. You have 20 electrons to distribute. So then you put 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 6, 6, 6. So you have all the first you give the 8 electron octet to the outer atoms, and then you have 2 more electrons remaining. You put in the phosphorus. You don't need multiple bonds. If you have any extra electrons, you still can put it on the center atom. One more situation. What if you don't have enough electrons to make 8 electron in the center atom? At that time, you can make a double bond or a triple bond and make 8 electrons. So that is how you draw the Lewis structures. Always keep in mind, identify center atom, calculate all the valence electrons, and then distribute all these electrons first outer atoms giving octet. And then look at the center atom. If center atom does not have 8 electrons, you can add a double bond or a triple bond and make the center atom. And then we talk about a little bit about the formal charges. So you need to know, okay, valence electrons, half bonding and non-bonding electrons. This is a formal charge. Formal charge is always you calculate formal charge each and every atom of a compound. Always lesser the formal charges, more stable the compound is. And then we talk about resonance. And then there are some exceptions for octet rule. Example, PF3 is fewer than, like, still make stable compounds other than making 8 electrons in the center atom. And then there are certain other exceptions. Some elements make stable compounds even it has more than 8. In this case, phosphorus has more than 8 electrons in the valence shell. So these are the concepts in chapter 8. I want you to look at the chapter 8 or read again, try to understand it, and then I hope this short video will help you to start the chapter 8. And thank you very much.